The next ones, we're going to use the Pythagorean theorem to find our missing side so that we can find cosine, tangent, sine, whatever they might ask for. So Pythagorean theorem says that a squared plus b squared equals c squared. So the two legs equals the hypotenuse. So 12 squared plus b squared would have to equal 13 squared. B squared is going to equal 13 squared minus 12 squared. You could figure those out, but I'm just going to put it in my calculator like that. 13 squared minus 12 squared is going to give me 25. So b squared equals 25, which means b equals the square root of 25, which happens to be 5. So that side is 5. We want to do the cosine. The cosine is the adjacent over the hypotenuse. The adjacent is 5, the hypotenuse is 13. So 5/13 is going to be my cosine. The next one. 5 squared plus b squared equals 6 squared. So b squared is going to equal 6 squared minus 5 squared. 6 squared minus 5 squared is going to give me 11. So b is going to equal the square root of 11. Can't do much with that. We want to do the tangent. Tangent is opposite over adjacent. So opposite is 5, adjacent is square root of 11. We have to rationalize that denominator. So 5 square root of 11 over 11. I'm just assuming that you know when you take the square root of 11 times the square root of 11, you get the nice plain 11. You get the square root of 121, which is 11. So skipping that, assuming that you can do that in your head, or if you need to, on your paper. And the next one here, if we look at number 18, we would say that 9 squared plus b squared equals 10 squared. So b squared is 10 squared minus 9 squared. 10 squared minus 9 squared is 19. So b squared equals 19. B is going to equal the square root of 19 then. And we are doing the sine. Sine is the opposite over hypotenuse. The opposite is the square root of 19. The hypotenuse is 10. So we get square root of 19 over 10 for our answer. So just using our Pythagorean theorem to find our missing sine and then doing our angle, sine, cosine, tangent, whatever they might ask for.